In this example, we're given a population which is being modelled by a recurrence equation. Looking at our recurrence equation, you can see that we are told the number of wombats when we start is 2,000. We are told the way in which the population of wombats change is wombats equals n plus 1. It says Kn, that should read Wn minus 100. So we're multiplying by a number bigger than 1, 1.06, and then we are subtracting 100. Now let's look at the question. The question says to us, how many wombats were initially? Initially means at the start, and at the start we know there were 2,000 wombats. So for part A, initially at the start, 2,000 wombats is our answer. Part B, it says, is the total population increasing or decreasing? So we need to consider that. If we look at our formula for the wombats is Wn1 equals 1.06 Wn minus 100. If I look at the 1.06 and I said, well, we're starting off with 2,000 wombats and go 1.06 times 2,000. What does that equal? Well, that's going to equal 2,120. That means if I was going to work out W1, I would go 1.06 times W0, and that gives me 2,120. Then I'm going to take 100 from it. Now taking 100 will give me as an answer 2,020. What that means is, after the first year, the population has increased. Now, the number for the number of wombats has got bigger. So what it means is, every time we multiply by 1.06 now, the number of wombats is going to increase by more than 100. So even though we're taking 100 wombats away, our population is going to continue to grow. It will be a growing population. Part C, at what percentage rate of growth is there? So if we look at the formula, we have got 1.06. 1.06 is 106%. Think of that as our R. R equals 1 plus little r on 100. So little r would be 6. So our growth rate is 6%. Part D says to us, how many wombats leave the population each year? We can see that there's 100 that are leaving each year. So our answer there is 100 wombats. E, use the recurrence equation to find the nearest whole number of wombats expected to be in the population after 4 years. Okay, now the question has said to us, use the recurrence relation. Now, looking at that, what we need to see there is it says use it. If this was an exam question or a SAT question, you'd have to demonstrate your use of the equation as we've done in previous examples. I have done this using a calculator where I have gone 2000, typed it in, pressed enter, and then typed times 1.06 minus 100. Calculator will then put answer here and gave me 2020. Pressed enter. That's what appears when I press enter again, and there's my answer, and repeat the process. Now notice I get to 2087.49. You've got to go to the nearest whole number. The nearest whole number then is 2087 wombats.